Moving on to question number 11. It's a previous IIT JEE question. A nucleus with mass number 220, initially at rest, emits an alpha particle. Okay. If the Q value of the reaction is 5.5 million electron volt, Q value means total energy released during the process. Okay. So if the Q value is 5.5 million electron volt, calculate the kinetic energy of alpha particle. So this is what happens. You know, we have a nucleus like this. Okay. A nucleus with a mass number of 220. Mass number of 220. Look at that. Mass number of 220. The nucleus has a mass number of 220 and it is undergoing alpha decay. Alpha decay like this. Alpha decay means a helium nucleus is emitted, right? Alpha particle is emitted. So it is what now? A part is being emitted. So it is 216 now. Why? Because an alpha particle has gone. Alpha particle has a mass of 4. Correct. Mass of alpha particle is what? Helium nucleus, He24, right? Alpha particle is nothing but a helium nucleus. Helium nucleus mass is 4. Helium nucleus mass is 4. So this is what happens. I have a nucleus of mass number 220, which is undergoing an alpha decay. And upon alpha decay, the new nucleus is 200 and having a mass number 216. An alpha particle should have a mass number of 4. Right? Because alpha particle's atomic mass is 4. All right, let's go on reading. The Q value of the reaction is given 5.5. Q value of reaction means total energy. Q value means total energy. Let us call this element by the name X. Okay, this is alpha. So EX plus E alpha. EX plus E alpha is given as 5.5 million electron volt. The total energy released is called Q value. So Q value for the reaction is given as 5.5 million electron volt. That means the total energy, EX, energy of X nucleus and energy of alpha particle. Okay, so let us keep it there and then come back here. What is the question? Kinetic energy of alpha particle is to be calculated. So I need one more equation here. No, I have two variables, so I need one more equation. So whenever you think of nuclear decay, the first thing to come to your mind is law of conservation of linear momentum. This is happening in accordance with the law of conservation of linear momentum. Which means what? Momentum of, after this process, momentum of X should be equal to momentum of alpha numerically. Momentum of X plus momentum of alpha should be equal to 0. All right. So momentum of this should be equal to momentum of this. Momentum of X is equal to momentum of alpha. So if I square it up on either side, Ps alpha square is equal to Px square. All right. But P can be written as what? Hope you remember this equation. E is equal to P square by 2m. Kinetic energy and momentum are related by this equation. E is equal to P square divided by 2m. So if you cross multiply, you can write 2me is equal to P square. So what have I done? I have taken law of conservation of linear momentum. Because this is a self-disintegration, so no external forces involved, momentum of the system must remain conserved. So before the process, the system was at rest. So initial momentum was 0. Final momentum is Px plus P alpha. All right. I would write here 0 is equal to Px plus P alpha. Take one to the left-hand side. Px is equal to minus P alpha. But minus simply tells you that it is going backwards. So forget about the sign. I take modulus only. Px is equal to P alpha. That is what I wrote here. Now, if I square it up on either side, it is Px square plus Px square is equal to P alpha square. All right. And then what is P? That is 2me, no? P square is 2me. So 2mxEx is equal to 2m alpha E alpha. I've just substituted for Px and P alpha here. Px is 2mxEx, P alpha is 2m alpha E alpha. And I can get these twos cut here. Mx, mass of X is 216 into E of X to be calculated. Mass of alpha is 4 into E of alpha. I don't know the value of E of alpha either, right? So I cut this and this, I get 54. 54 fours are 216. So I got the value of E alpha here. E alpha is 54 times Ex. Okay, 54 times Ex. All right, so I can put it here. Tell me, I can put in place of E alpha, I can put 54 Ex. So I put it straight away to this equation. In place of, so Ex is Ex itself, plus in place of E alpha, I have a substitution. It is 54 Ex. 54 Ex will be equal to, what is the right hand side? 5.5 million electron volt. So if you add them up, 55 EX, 54 EX plus EX is equal to 55 EX is equal to 5.5 million electron volt. Take it to the right hand side. Energy of X is equal to 5.5 by 55. This and this are cut. It is 10. 1 by 10. That is 0.1 MeV. I got energy of EX, energy of this nucleus. So energy of alpha can be easily found out. This is 0.1. EX is 0.1. EX is 0.1. Then this must be what? This goes to the right side. E alpha will be 5.5 minus 0.1. That will be 5.4 MeV. Answer is option. It is given. Answer is option B. Second option is correct. So previous ITJ questions. Quickly repeat this. We have an alpha decay happening. We have a nucleus with a mass number 220, and then it emits an alpha particle. So its mass number decreases by 4. Alpha particle is helium nucleus. Helium nucleus mass number is 4. So this has a mass number of 4. The remaining nucleus will have a mass number of 216. 220 minus 4 is 216. And then I told you, in such an alpha decay, momentum is conserved because it's a self-disintegration process and no external forces involved. So law of conservation of momentum holds good here. Okay, momentum before the event is equal to momentum after the event. Before the event, that means the nuclear decay, this was at rest. So momentum is 0. After the event, the momentum for this guy is Px, momentum for this one is P alpha, momentum of X plus momentum of alpha. I take it to the left side, Px is equal to minus P alpha. I'm not bothered about the minus sign there. So I simply take the modulus, Px is equal to P alpha. And let's come back here, Px is equal to P alpha, I square it up, Px square is equal to P alpha square. And I write P in terms of mass and energy because I've been asked to find energy in this case. You know, E is equal to P square by 2m, relation connecting energy and momentum. And if you cross multiply, you're going to get what? 2me is equal to P square. So 2mx Ex is equal to 2m alpha P alpha. 2's are getting cut on either side. Then I put mass of X, which is 216, into E of X. Then mass of alpha, which is 4, into E of alpha. 4 and 216 are again cut. You're getting 54 on the left side. 54 Ex is equal to E alpha. This is an intermediate equation. Now I can solve this equation with this one. I have two equations. I have two variables. So simple now. In place of E alpha, I'll put E 54 Ex. So Ex plus 54 Ex is equal to 5.5. So Ex plus 54 Ex equal to 5.5. So 54 plus 1, 55 Ex equal to 5.5. 55 and 5.5 cut, you're getting 10 here. 10 is taken to the right hand side. That's leaving you with Ex is equal to 1 by 10. That is 0.1 MeV. But the question is not to find Ex. We need to find E alpha. Alpha is what? E alpha. E alpha I can find from here. This goes to the right side. 5.5 minus Ex. 5.5 minus Ex is 0.1. So 5.4 MeV. And for solving this question, you should know one thing beforehand. Q value is actually the total energy released. Energy of X nucleus plus energy of alpha particle.